Okay, today we're going to take a look at the quotient rule for exponents. In our first problem, notice that we do have a division problem. We have 7 to the 8th power divided by 7 to the 5th power. We're going to write this in expanded form, so we better understand how to solve it. Notice that 7 to the 8th means I'm going to take the base of 7 and multiply it by itself 8 times. So I'm going to write that 7 times 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 7. 1, 2, 3, 4, 5, 6, 7, 8. Then we're going to divide by 7 to the 5th power. So I'm going to take 7 and times it by itself 5 times. 1, 2, 3, 4, 5. Now, if we remember back to simplifying fractions, remember that 7 over 7 becomes a 1. And another 7 over 7 becomes 1. This one becomes 1. This one becomes 1. And then we have one more last pair that becomes 1. And so now I'm left with 7 times 7 times 7. And I can rewrite that as 7 to the 3rd. Notice down here I have all 1, so it is over 1. So my answer is 7 to the 3rd power. Now let's go ahead and try that with a variable. I have x to the 4th divided by x to the 2nd. I could expand that and write it as x times itself 4 times. X times x times x times x divided by x to the 2nd power. That means I'm going to multiply x by itself 2 times. X times x. Now, same thing with fractions and using numbers. If I have a variable over its same self, it becomes a 1. And then these become 1. And I'm left with 2 x's. So I would rewrite that as x to the 2nd power. Notice any patterns going on? Remember, for multiplication, we added our exponents. What are we doing with our exponents in this one? Notice that I have 8 in the numerator, 5 in the denominator, and then I have an answer of 3. 8 take away 5 is 3. Let's take a look at our second problem. If I have a 4 in the numerator as an exponent, and I subtract 2 from the denominator, I get the answer of 2. So our rule is, when dividing, if the bases are the same, keep the base and subtract the exponents. So let's go ahead and try a few of these. Notice in this one I have x to the 5th divided by x to the 7th. I know that if I have the same base, they both have a base of x, I'm going to keep my base, so I'm going to write x. And then I'm going to subtract the exponents. Now, order does matter, so it's you write the numerator and subtract the denominator. That sometimes will leave you with a negative exponent, and that's okay. 5 take away 7 is a negative 2. And right now, that's where we stop. Let's take a look at our second one. I have m to the 8th divided by m to the 3rd. Since my bases are the same, and I'm dividing, I'm going to keep my base of m, and I'm going to subtract the exponents. So I have 8 minus 3. If I solve that, I get m to the 5th. Okay, so now it gets a little bit trickier. Notice that I do have numbers here that don't have exponents. So I'm actually going to do division just like normal. This is 15 divided by 5. 15 divided by 5 is 3. Now I do have exponents. Notice my bases are the same. So I'm going to keep my base of x. And then I'm going to go 4 minus 2. That simplifies to 3x to the 2nd power. So notice when I have whole numbers, I actually divide just like normal. When I have exponents, that's when I use my special rule. Okay, our last one looks different. So what we can do is we can actually follow the same rule. I have bases of 12, so I'm going to keep my 12. and then I'm going to subtract them in the order that they're already written. So notice that I have a 10, and I'm going to subtract a negative 15. So here we have to remember our integer rules. If I am subtracting a negative, it is the same thing as adding. So I am going to actually add 15. Remember, when you subtract a negative, it's the same as adding a positive. So this simplifies to 12 to the 25th power. And that is the quotient rule for exponents.